Okay, so last time, again, we went through 4.1. So we'll look at some of these questions that we asked about. Now, 4.1, what we were looking at is inverses. Okay, so remember, when we talk about things that have an inverse, that means that they are one-to-one. And some of the first questions just ask us to determine if the function has an inverse. And some of the later questions, if it has an inverse, we need to find the inverse. So question 5 asks us to find the inverse if it has one. Okay, so what does an inverse mean? Well, inverse is like the opposite. So we're going to start with our original function here, and it's a cube. Now, when we talk about cubes, cubes have an inverse. What does it? Squares, unless the square has a restricted domain. So this one obviously has an inverse. So step number 1 is always decide if the function has an inverse. So this one does have an inverse. Okay. Now, what do we need to do? Well, we need to replace f of x with y. And then we replace x with y and y with x. So we switch or swap them out. So that becomes x equals now 6y cubed plus 4. And we're on the right track here. So what do we need to do now? Okay, right now it's solved for x. We want to solve it for y. So we move that 6y over. Or, sorry, we can just move the 4 over. That's probably going to be our easiest, is to just move that 4 over. Find a pen here that works. And that leaves me then with 6y cubed equals x minus 4. Okay. And what do we need to do from there? Well, we need to get rid of the 6. So we'll divide everything by the 6 here. And now we've got y cubed equals x minus 4 over 6. And how do we get rid of a cube? Remember, we talked about this before. When we did a square, we took the square root. We have a cube, so that means we have to take the cube root. Okay. So we're going to take the cube root of both sides. And that now leaves you with y equals the cube root of x minus 4 over 6. And what do we need to do for the last step? Very last step is we replace that y with f inverse. So f inverse of x is going to equal the cube root of x minus 4 over 6 there. Okay, adjust this a little better here. That's what we did. So what did we do? We went through, let's kind of review the steps. We went through and we replaced that f of x with y. Then we switched out or interchanged your x and your y. Then we had to resolve it now for y. And then once it's been resolved for y, then we went and switched out or interchanged, switched out that y for that f inverse of x, and that gave us our final answer. So that's what we did on that. So let's go ahead and try another one. And it looks like that would be answer what? Okay, if we're very careful here, just to make sure, because I did give you multiple choice on these, this one looks like it's going to be answer what? Answer B, isn't it? Be very careful with your signs when you work these out. So that was question 5. Now, question 6, we need to see if it has an inverse. And I think it does, even though it has an x squared, right? It's still going to have an inverse. this is what we've got here. And they say that x has got to be greater than or equal to 5. Now, what's going to happen when I plug values in that are bigger than 5? All right, our domain is x has got to be bigger than 5. So if I plug in, let's say 6, we just figure out what the sign's going to be. If I plug in 6, okay, 6 squared is 36, and 36 minus that 25, that comes out to be 11, okay? And then the square root of 11 is positive, but what's out in front of it? Negative. So what's your y going to be? Y is going to be less than or equal to 0. Why? Because when you plug values in, what's going to happen to my answers? My answer is going to be positive or negative. We just plug something in to see. So if I plugged in here a 6, because 6 has got to be bigger than 5, that's 36 minus 25, that's 11. Square root of 11 is positive, but what's out in front of it? Negative. So that gives you your y has to be less than or equal to 0. Now, why is that important? Okay, that's going to be important because when we finish our answer, that y, remember, becomes your x value. That becomes your domain of the answer. So you've got to make sure we've got the 0 going in the correct direction. Okay, so it's going to be y is less than or equal to 0 because the negative part there. Now we can finish it. So it does have an inverse because we've restricted the domain. And we're going to replace f of x with y. Then we switch the x and the y, swap them out. Okay. Now here's where we have to be careful about our signs. We want to get rid of a square root. So how do we get rid of a square root? Well, we have to what? Square. Okay, square will get rid of a square root. But what happens when you square a negative? When you square that negative, it becomes what? Positive, right? So that's going to leave me then with x squared equals, square negative becomes positive, square and square root cancel, so x squared equals y squared minus 25. Okay, and it became positive. Now, what do we need to do? We need to now resolve this for what variable? We need to resolve this for the variable y, because x and y got switched around. So we're going to add 25. And that leaves me now with y squared equals x squared plus 25, right? And our last and final step is how do we get rid of the y squared? It's a square. So what gets rid of a square? Square what? Root. Now we don't have to worry about the plus or minus because it's been taken care of with our domain up here. So we don't have to worry about the negative case at all or the positive case because it's already done. And what does that give you now? Okay, that gives you y equals the square root of x squared now plus 25, and we replace y with f inverse of x. And what about our domain? Okay, well, what was our range up here? Okay, our range was y was what? Less than or equal to 0, so that gives me my domain as as x is less than or equal to 0. That was the most complicated one to work through. And so which one does it look like here? Okay, we got to watch the way that it goes. It looks like it's going to be answer what? Answer C, isn't it? Because that's what we've got. Okay, make sure it's all the same. We've got the plus. We've got our x going in the correct direction. Should be answer C there. Is everyone all right with that one now? Okay. So now let's move on. And let's now look at question 8. Similar again. Question 8 has an inverse. By the way, why does 7 not have an inverse? Let's talk about that. Sorry, 7 has an inverse, right? Well, no, 7 does not. Why does 7 not have an inverse? Why would 7 be not 1-to-1 and have no inverse? Well, on the previous one we had a square, right? But the domain was restricted. This one doesn't. So it's going to make a U, and if it makes a U because of the square, it fails the horizontal line test. So 7 would not be 1-to-1, right? And if it's not 1-to-1, it has no inverse. So that's why 7, just to make sure we know, would be answer A. It has no inverse, and it is not 1-to-1. Question 8, though, has an inverse. So for question 8, we've got f of x equals 8 over x plus 8. Okay, so how do we know that this one has an inverse? Well, what does not have an inverse? Okay, things that do not have an inverse have a square and a restricted or anything else that's an even power. So this doesn't have any powers, it's just a fraction. So this one would have an inverse. Does anyone need the homework packet for 3-7 and 4-1? Yep, you might need one there. You're welcome. Okay, everybody else? Yep, do you need this one from last time as well? Yep, you're welcome. And I've got a new packet I'll pass out here in just a minute. That was a one from last week. Okay, so we were on question 8. So first thing we did was we determined that it does have an inverse. What doesn't have an inverse? Squares, when they don't have a restricted domain. So this has an inverse. Now, what do? Replace f of x with y. Simple enough. We swap out or interchange your x and your y. Bless you. And now what do we need to do? We need to now resolve this, and we're going to resolve this for the variable y. So we first clear our fraction by cross multiplying. So that's that piece there. Now distribute your x through. So let's go ahead and distribute our x through. And that gives you xy plus 8x equals 8. We'll move the 8x over. And xy equals now 8 minus 8x. And divide by your x. And we now have our inverse. So y equals 8 minus 8x over x. And that gives you f inverse of x equals 8 minus 8x over x. And it might be in a different order. Looks like answer C to me, right? Because I just put it in a different order than what they have. Because if we look at answer C, it looks like that, doesn't it? Mine just in a different order is all. I just wrote the x behind, they wrote the x in front. So this one would have answer C for the correct choice there. Okay? Is everyone all right with that? So we cross multiply, distributed through, moved things around, and solved it. And then we replaced our y with the f inverse of x. One more to look at, question 9. All All right, and this one's pretty easy to work through. Now, this one has an inverse, right? Cube roots have an inverse. Replace f of x with y. Switch out the x and the y, so that gives you x equals now the cube root of y plus 3. And we need to get rid of a cube root. So how do we get rid of a cube root? We have to what? We have to cube both sides. So we'll go ahead and do that. Now once we've cubed both sides, then we get x cubed, right, equals now y plus 3. And one more step, move that 3 over. And y equals now x cubed minus 3. And what do we do for our final step? We replace y with what? F inverse of x. So that's going to be your final answer on that one. So it looks like that would be answer what? Answer D, isn't it? So is everyone okay with how we did the inverses there? So what makes something not have an inverse? It's a square. Square or even powers. We don't do any other even powers, but anytime you have an even power, that makes a U-shaped curve, and that would fail the horizontal line test. So those do not have an inverse unless they restrict the domain. If the domain is restricted, like x is greater than or equal to 4 or 5 or something like that, then it has an inverse and you solve it. That takes care of the questions out of 4.1. So what we're going to be looking at today is 4.2. So I'll go ahead and pass out your new homework packet. Right packet here. Here's the new homework packet. And just remind us, Scott, that all the homework that you need printed off. So if you haven't printed it off and haven't started up, but all the homework that you're missing, I've got it for you. Just remind me and I'll give that for you. Give that to you before you leave today. Okay, let me find the other homework packet here. Okay. Okay. So now we're going to go ahead and start looking at 4.2 today. So we don't have a lot of material left to cover. We still need to finish up Chapter 4 and Chapter 5 before the end. We're not going to have another exam except for the final exam. So one more exam and that'll be your final. Now, your final exam is going to have a little bit of everything. It'll have applications, it'll have graphing, it'll have what we're covering right now. So you've already should have seen that practice final. If you haven't seen the practice final, let me know. I have it up here. I can give you a copy of it. We passed that out last week. I gave it to you early. That way you can start working on things. And just so you know, for your final, you're going to have an in-class one as well as a take-home one. And the take-home one is just designed to get you ready for your final exam. But that's going to be a while off. We're not going to have any more exams except for the final. So we'll cover Chapter 4 and Chapter 5, and then we'll have our final exam. So today, we're going to go ahead and work more in Chapter 4. And we're going to do 4.1 today. And we will do 4.3 next time. So 4.2 is exponentials. And these have their own unique graphs. If we look in the back cover of our textbook, we're going to see, in 4.2 down here, we're going to see graphs of our exponential functions. And you have one where your base, the number down below, is bigger than 1. And one of them where your base, the number down below, is between 0 and 1, less than 1. So they have different graphs based upon the base. And what we do is we pick the 3 points. So you've got 0, 1, that's the common one. We've got 1, comma a, and we've got minus 1, comma 1 over a. So that makes your exponential graphs like that. So let's start off with a really basic one that's easy to work with. And again, we're in 4.2. We're going to try and graph this function. How about f of x equals 4 to the x power? Now, when we go to graph this, 4 is definitely what? Definitely bigger than 1. So the graph is going to look like this. It's your base, your 4, is bigger than 1, so your graph is going to resemble that. If it's less than 1, it looks like the other picture. When we go to graph it, are we moving the graph up or down any? No. It's not shown in your picture, but you have a horizontal line here for an asymptote again at y equals 0. So that's always there. Now, the next point that we have to have is we have to have 0, 1. So 0, 1 would be right here. So we have to have that 0, 1. Now, what is my base? My base is 4. So that means my next point is going to be over 1 and up 4. Right there at 1, 4. Now, we can do another point if we need to, or you can use this as enough. I usually like to do the 3 points. So we have 0, 1, that's where we start at. We have 1, 4, and then we go back 1, and we go up a 4th. Not 4, we go up only a 4th. So my next one is going to be back here at minus 1 and 1, 4th. And when I connect them together, there's my point there. When I connect them together, it's going to make a curve, and it's going to resemble that. Because this 1 over 4, well, that is 1 over a, and a is this 4. So a is the base. We didn't move it up or down any. We didn't shift it around. All we did was make it go over 1 and up 4 there. We're going to do another one. So let's try and graph. How about 1/2? X, and then let's do a plus 5. So this one has multiple things that we're working with here. It should have a parentheses around this. What about that 5 on the end? What do you think that 5 is going to do here? It's on the end, so that's going to force your graph what? That's going to force my graph up 5. Now, 1/2 is less than 1, so your picture will look like this. So it's going the opposite way. Why is it going the opposite way? Because 1/2 is what? Less than 1, and that is your base. So this is the base here. That's your A. And if A is less than 1, the picture looks like that. The other one, 4 was larger than 1, so it went up. Now, where are we going to start at? We're going to start 5 units up. So that means my dotted line is up 5. So it got shifted up 5 units. Now what do we do? Okay, well, where do we start at? 5 units up. We're actually going to start now at, normally we start at 0, 1. Now we're going to start at 0, 6 because we went up 5 units. And normally it's just 1 up, but now it's 6 from the bottom, 1 from my asymptote there. Okay, now, what do we know about our points? Well, our point is we've got 1/2. Okay, so that means that we're going to go over 1, up about 1/2, so that's going to be there. Okay, that point is going to now be at 1, 5.5, right? So we had to go over 1, and we started at 5, add 1/2 to it. What do you get? 5.5 there. What about the other side? Well, if this is my A, if 1/2 is the A, when I flip over A, what does it become? It becomes 2. 2 plus 5 makes it then a 7. So that's going to be up here at -1, 7. And when I connect the pieces together, the graph is going to resemble that. That's what the picture will look like. It's just going to be a curve going up this way. Why? Because 1/2 is less than 1. Let's do one more of these. And then we'll talk about these exponential equations and how we go about solving them. So we'll look at one more that we're going to graph. So what is this going to look like? Well, 3. 3 is definitely bigger than 1. So since 3 is definitely bigger than 1, my graph is going to look like that. Okay. What about the 4? What do you think that 4 is going to do? It's on the end, so that moves it up 4. What about this negative here? That negative is going to do what to it, do you think? Okay, that negative is going to flip it over, isn't it? Right, because it's up to a power. It's a negative there. That's going to flip my graph over. Actually, I should put the negative in front. Let me put the negative here, just so it makes more sense. Okay, so it should actually be in front. Make sure it's in front of that 3, not to the power. My mistake there. So that negative here is going to make that flip over, because that's negative. Okay, make sure. I just put the negative in the wrong place. So that negative is going to make it flip over, because that's like your slope. Okay, so where are we going to start at? We're going to start up 4 units. So that means my horizontal line is here at 4. So we do that first. That is my horizontal asymptote. Now it's going to look like this, but what's going to happen to it? Okay, instead of it being up here, right, it's going to be down here. Why? Because the negative is going to make it do what? Flip over. So same points are still going to be here. We're going to be at 1 unit down. So that's going to be at 0, 3, because it's below now. Okay, negative 3. When I flip over, well, doesn't matter which way we work. When we have the negative 3, that means we're going to go back 1 unit and we're going to go down 3. So 1, 2, 3. It's going to be right there. Okay, so there's that piece. And that's going to be at 1, comma 1, right, because you have a minus 3. We're starting at 4. Gives you that 1, 1 there. Now, what about the other one? Okay, we're going to go back 1. And what's the reciprocal of 1/3? Or of 3? 1/3. So that's going to be back here. And that's going to be right here at the point minus 1, comma, take away a quarter from this 4. So that's going to be 3 2/3. When we connect them together, what does my picture look like? My picture looks like that. Now, what am I going to be concerned about when I check this for accuracy? First things first, I want to make sure that you have that horizontal line at 4. That's important. Second thing I'm going to look at is make sure you either go up 1 or you go down 1 from this horizontal line. It's negative, so we're going to start right here, 1 unit down. So that's going to be at that 0, 3. Okay, that piece is what we need. Now, the other two just kind of help you make sure you're on the right track. But what I'm going to basically be looking for is make sure you have the 0, 3, and make sure the shape of the graph looks like that. If you want to add in the extra points, you can. But make sure that it's horizontal here at y equals 4. Make sure the shape of the graph is going down in this direction. That's how you would work out and graph an exponential like that. So those are the key things that I'm looking for. Make sure the shape is right, and make sure in this case that you've moved it up to 4 units. Okay, so I gave you a couple of those to look at. Now let's look at how to solve these exponential equations. When we go to solve these exponential equations, depending upon what it is going to be how you solve it. So some of these we're going to be able to look at and just guess the power. So for example, this one. All right, we're going to start off with a very, very easy one. This one you can almost just look at and see what the answer would be. Does anyone think they know what x might be in this case? Does anyone want to take a guess as to what they think x would be? If I gave you this equation and I said solve it for x, can someone tell me what they think x would be? Just by looking at it. 2, okay? How did you get that? Okay, you got it just by looking at it because you know that 6 squared is what? 36. Okay? Now, when we go to solve these, sometimes we may have to rewrite them to get a common base. But what I would have done is I would have done this. Okay, we can look at it and we can say that x is 2. That's easy. We can see that. But what we want is a common base. Well, we know that 36 is 6 what? squared. Now, once the bases, these are our bases here, if the bases are the same, then the exponents must be the same. So we know that the bases are the same, so the exponents must be the same. So we know that x is going to be what now? 2. Now that one you could have gotten just by looking at it, right? Because you know that 6 squared is what? 36. But if you didn't see that, what you want to do is you want to work these out to where you get a common base. So let's try another one. So let's try and solve this one. Okay, this one you may or may not be able to just look at and see what it would be. But what we want is we want to take 2 to some power and it give you out that 16. So we want a common base. Now we take the larger number, and so the larger number is going to be our 16. And we want to turn it into a power of the smaller one. So 2 to what power makes it 16? Let's take a calculator and see. If we try 2, 2 squared is what? 4 doesn't work. 2 to the third power is 8, doesn't work. But what about 2 to the fourth power? 2 to the fourth power is what? 16, and that's what we want. So now we can write this as 2 to the x power equals 2 to the fourth power. The bases are the same. So that means the exponents must be the same. So therefore, x must equal what now? X must equal 4. Let's try a little bit different one. All right, so this one. A little bit different. Same concept though. We look at our larger number. In this case, it's a 125. And so 5 raised to what power is 125? Can anyone tell me? 5 raised to what power? Okay, 5 squared is 25, right? 5 cubed is what? 125. That's what we want. So now we can write this as 5 to the x minus 7 power equals now 5 cubed. The bases are the same. So if the bases are the same, then what do we know about the exponents? Well, we know then that x minus 7 is going to equal what? 3, right? Because the exponents have to be the same because the bases are the same. Now we can finish it. So we add our 7. And now what's our value of x going to be? X is now going to be what? 10. So easy enough there. In some cases, you may have to use the negative exponent rule on these. So let's just review the negative exponent rule. Okay. The negative exponent rule is this. A to the negative n is 1 over a to the n power. So in some cases, we may have to use the negative exponent rule because one side may be a fraction and one side may not be. And we could use that to flip them over. So let's do another example. How about we have 27 to the x minus 8 power equals 1/3. Okay, and there's multiple ways of working with this. What we want to really try to avoid is we really want to try to avoid fractional powers as much as possible. And if we have a fractional base, remember the base is the number below, we need to flip it over. And we need to make sure that these are whole numbers as much as possible. So the first thing I can use is this. I can use our negative exponent rule. So we know then that 1/3 is the same as 3 to the negative first power. Right? That's our negative exponent rule. So we can rewrite this. So that's the first thing I did, was I flipped it over. Is everyone okay with that? So whenever you have a fraction, you could flip it over by using the -1. Sometimes you may need to flip it over and use powers as well, but you can flip these over by using the negative exponent rule. Now we need to work with this. So we know that 3 raised to what power is going to be 27. Okay, 3 raised to what power is going to be our 27? 3 cubed, right? 3 cubed is your 27 then. Okay, so now how do we rewrite this? Remember, we looked at the bigger number, which bigger number was 27. So I can rewrite this 27 as 3 cubed. Now, use parentheses because that 3 is going to have to be distributed through. So you have to use parentheses here because 27 is what? 3 cubed. Now, what do we know? Now we can finish it because we now know that the bases are the same. Bless you. And if the bases are the same, then what do we know about the exponents? Then we know the exponents must be the same. So we have 3 times x minus 8 equals now a -1. And we can now finish this out. All right, so pretty easy on this. We just now distribute that 3 through. And that gives you 3x minus, we need to distribute through, 24 equals a -1. Add that 24 to each side. And we have 3x equals now 23. Divide by our 3. And so x now equals 23 over 3. And that's going to be your answer on that. Okay. Let's look at another one. Okay, let's look at another fraction one. About 36 over 25 to the x minus 5 power is going to equal 5 over x to the 6th, 5 over x to the 6th to the, how about 4x minus 1. So again, we're going to try and solve this. Now this one, we first need to look at it and see how we can proceed. So the first thing I look at is I look at this. And I see how all of it goes together. Well, I know that 6 squared is what? 36. And I know that 5 squared is what? 25. Right? See how they relate there. So what do I first need to do? Okay, this one's a 36 on the top. It goes with that 6. So I'm going to have to flip this over somehow. So one of them is going to need to be flipped over. Doesn't really matter which one, but one of them gets flipped over. So I'm just going to flip over the 5 over 6. So 5 over 6 to the negative first power, when I flip that over, is going to give you 6 over 5. So that's what I'm going to do. I'm going to rewrite this now as 6 over 5 to the negative first power, because they're inverses of each other. Again, they flip over, equals that 36 over 25 to the x minus 5 power. So the first thing I did was I flipped it over. Because you can flip them over either way. I need to go ahead and, just to make sure I don't make more mistakes, distribute that negative through. So that negative there is going to be distributed through. And then we'll see what to do from there. So distribute that negative through. So that's minus 4x. And negative makes it a positive 1. So that's what we've got. Now, how do we proceed from here? Well, what do we know about the 36 over 25? How does it going to relate to 6 over 5? Can anyone tell me what power? Squared, right? Because we know that 6 squared is what? 36, and 5 squared is what? 25. So we take the larger number, so this one's we got the larger numbers, we make it into the smaller one. So that's going to be 6/5 now, the second power. Now use parentheses with that 2. We still have that x minus 5, and that equals 6/5 to the minus 4x plus 1 power. And now it's almost all done. So now what do? Have we gotten to the point where the bases are the same? Yep. Once the bases are the same, right, then exponents must be the same. So that means if the bases are the same, then the exponents are forced to be the same. So now we've got 2 times x minus 5 equals minus 4x plus 1. And this is something that we can solve, right? Because we're quite capable of solving this now. So the bases are the same, so that forces the exponents to be the same. Distribute our 2 through, and that leaves me then with 2x minus 10 equals a minus 4x plus 1. We'll add that 4x over and add 10 over as well. And now that gives you 6x equals, that should be adding there, right, because we're going to move that 10 over with addition. And 6x now equals 11. And so x equals 11 over 6. So is everyone all right with how we solve these? So what do? We use negative exponent rule to flip fractions over if we need to. And we always take the larger number and try to figure out what power of the smaller one gives you the larger one. And then once you rewrote it, then you make sure that the bases are the same. That forces the powers to be the same. And then you've got an equation that you can solve. We're going to look at a few examples of applications, and these are just plugging numbers in, is all these are for the first ones. And then we'll talk about compound interest. So I'm going to pick a couple of these from our textbook to look at for the examples here. So, for an example, I'm on page 462, and I'm going to look at question 109. We're only going to do part A. So only do part A. Now, exponentials are used for modeling. Population is based upon a model, on an exponential. Population, once it starts growing fast, it goes really, really fast. Same thing with bacteria. Okay, bacteria grow at it's what's called an exponential rate. You can also have exponential decay, and that happens with radioactive isotopes and things like that, where they decay at a certain rate. So when we look at exponentials, they're used in modeling and predicting things. So 109, we're only going to look at part A. So the exponential growth of the deer population in Massachusetts can be approximated by this model, where the 50,000 is the initial deer population, and the 0.06 is the growth rate. F of x is the total population after x years have passed, and want to find each value to the nearest 1,000. So we want to predict, and we're only going to do part A, because this is what your homework looks like. We want to predict the total population after 4 years. So that's what we're going to try to do, is find the initial population after 4 years. So we've got our model. We want to find the population after 4 years. And this is on page 462. We are looking at question 109. This is very, very similar to question 9 in your homework. You just plug the values in. And we're also going to talk about what E is in a moment as well. So 109, we've got this. We've got f of x for our model equals 50,000 times 1 plus 0.06 to the x power. And we want year 4. So if we want year 4, well, that means that x is going to be now 4. So we're going to plug in 4. And when we plug in 4, that's going to give us our deer population. So how would we work this out? Let's remember our order of operations. So we're going to plug in our 4. And when we plug in our 4, what do we do first? Well, the first thing we have to work with is our parentheses. So we're going to put that 1 plus the 0.06 together. So that's going to give you 1.06 to the 4th power. Okay, so we put those together. Now, I'm going to show you how to use your calculator for this. I've got 2 different types of calculators. So this way you can see, depending upon which type of calculator you have, how you get this to work. And the other calculator's around here somewhere. Find it. So I think I have another one. Yep, here it is. Okay. So I've got 2 different types of calculators. I'm going to show you how to work through this question. So the first thing we did was we added them together. I'm going to share the most common type of calculator first. So a lot of you have a calculator like this one. Okay? There's two different types of calculators. I'm going to show you both. But a lot of you have this type of calculator. How would I work this out? Well, the first thing I do is I type in my number, so 1.06, and then you'll see the caret. So if your calculator has a caret key like this, you'll hit your caret key, you'll hit your 4, and then you hit the enter. Now, we're not completely done yet, because then what do we have to take that times? We have to then take that times our 50,000. And that gives me then this. Now, what do they want? They want it to the nearest thousandth. So to the nearest thousandth then, this would be, when we round, it looks like 63,000. So we would predict, if we have 50,000 deer in 4 years, we would have 63,000 deer. Okay, is everyone all right with how I did that? Now, another type of calculator that you may have is this type. So many of you may also have this type of calculator. And this type of calculator has a YX key. So how would I use this type of calculator? Well, we type our same number in again, 1.06. Instead of the caret key, we use the YX key. So we hit our YX key right here. We hit the 4, and we then hit equals. And then what do? Multiply that then by our 50,000. And that gives me then the same result. So you're either going to have a caret key like this one, or you're going to have a YX key, one or the other. It'll either be this or this. Most of you have the caret key. So on these applications, all you have to do is plug in the value that they give you. Now let's talk about an exponential. And I think there's an exponential one that we can look at as well. We did one with power like that. Let's look at 108. I wanted to do 109 first because I think it's the easier one. And it's the one that we're most familiar with. 108 uses what's called an exponential, an Euler's number, the E. So this is world population growth. The world population growth comes from this equation. Now this has an E. And E is just like pi. It's a number. And it's built into your calculator. So we're going to just do part A. So here's our example. Okay. The world population was about 7,346 million in 2016. How closely does this function approximate this value? Now, what is x? We have to be very careful with what x is. X is the number of years since 2000. So x is the number of years since 2000. So let's write up our function. Here's our function. F of x equals 6,103. Now we have e, which is something new. E to the 0.01167x. Okay, so this is something new. I'm going to show you how to use your calculator for this one. Now, x is the number of years since 2000. So x is the years since 2000. Now we want 2016, right? So we want 2016, that's 16 years later, so we're going to be using x equals what? 16, right? Got to watch how they're labeled. In this case, it tells you x is the number of years since 2000. So we want 2016 to compare. So that means my x is going to be 16. We're going to plug it in. And I'm going to show you how to use each type of calculator to come up with the correct answer. So I plugged in that 16. This is very, very similar to question 9 from your homework. It's almost identical. Different numbers are plugged in. That's the only difference here. Now, what are we going to do from here? Well, the first thing we always want to do is we want to do our multiplication first. So let's take that 6103E, and I'm going to go ahead and multiply those together. So let's go ahead and finish out that exponent first. So we've got 0.01167. Make sure it's right there. Correct number of zeros. We're going to multiply that by our 16, and that gives you that. So 0.18672. Is everyone okay with that part? Right? So we did that first because that's your multiplication. Now, how do we come up with our answer? Well, we come up with our answer by using a function that's built into the calculator. What E is E is just a constant. It's like pi. We're going to work this out in a similar way to the last one. I'm going to try to get this where we can see it up on the screen here. This is one type of calculator that you may have. So, if you have this type of calculator, you're going to find the ln. You see that button that says ln. And see right above it, in that purplish blue, that is e to the x, and that's what we want. Now, how do we get to that function? We use the second key. And exponents are always done first. So what we do is we hit our second, and we hit the ln. Now that's going to put that E right on the screen. That's what we want. We're going to go ahead and fill that in with 0.18672. And then we hit our equal key. And that gives us that. Now, what do we still have left to do? We still have to multiply it by what? We still have to multiply it by 6103. And that gives us now our answer here. Which our answer, and we're going to go ahead and round it to one place. That's probably going to be close enough. That comes out to be 7355 if we round to 0.9. And that is in millions, right? So that's the number of people that are on the planet Earth. Now, what do we know about the true population? Well, it says the true population, from our question here, right? Our true population should be 7,346 million. What did ours come out to be? Ours came out to be pretty close, didn't it? Right? So it's fairly close to the true population. So this model can be used to predict the population, and it's fairly close. A lot of things that can happen can change that, but this kind of gives you an idea of what the population should be. Now that E key, again, is built into your calculator. If you don't have that, if your calculator looks like this, you're going to work it out the same way. If your calculator looks like this, you still have the ln key. Okay, so it's going to be worked out the same way. It just doesn't display it on the screen. So you'll type your number in. The exponent, first we'll type in that number, 0.18672. Now, for this one, it's a little bit different. We hit inverse ln. That gave you that. And then we multiply it by the 6103. And that gives us the same value. So either type of calculator that you have, what are you going to look for? ln. This is called the natural log. And in a later section, when we talk about logarithms, we're going to learn that ln is the natural log, log base e. And it is the inverse of e to the x. So on your calculator, whenever you want to use that e, you're going to want to find the ln. And you'll either type second ln first, and then your value, or you'll type in inverse ln. So let's go over it one more time with the... Sure. Yep, no problem. Okay, so let's go on, and let's do this one again one more time. How would I put this in my calculator? Most of you have this type. This is the most common type of calculator that you have. Do we have? So let's go over again one more time how to work this one out. What do? We type in our exponent first. Sorry, our second ln first. Because yours is going to display on the screen exactly as it needs to be. Put that e up on there, right? Most calculators look like this. We'll do the other one just as well. Okay, but you'll put that e up on the screen. What's my power? 0.18672. Right? Hit enter. And then what do we still have to do? Multiply it by the 6,103 out in front. That gives us that. Right? Okay. The other type of calculator, how would it work? If you have this type, which some of you may have, how does this one work? A little bit different. Type in your value first. 672. You have to hit inverse ln, hit equals, okay, and then multiply it by the 6103. That gives you then your value. Is everyone okay with how to do it in the calculator? You'll either have one type of calculator or the other. Now, if you're using a cell phone, it's going to work the same way. Most cell phones probably have, depending upon the type, whether it's an Apple or an Android, it's probably going to have, in most cases, most cell phones use the YX key. Now we've got one more short topic left to cover, and that is compound interest. How banks compound your interest is using this formula. Whenever you take out a loan at a bank, it uses compound interest. And your compound interest is this formula. We're going to be talking about our compound interest formula. And our compound interest formula is on page 454. And here's our formula. A equals P times 1 plus R over N to the Tn power. What do all the pieces mean? A is going to be the ending value, sometimes called the future value. So if you take a finance course, you're going to hear that term future value. So that's how much money you would have at the end. P is the starting value or the principal. R is the interest rate as a decimal. T is the number of years. And very important here, N is compoundings per year. So let's just focus right now on our N. N is the compoundings per year. So if I said I'm going to compound this annually, that means N would be 1, because you're compounding it once a year. If I said monthly, N would be what? 12, because there's 12 months in a year. If I said quarterly, what would N be? 4, because there's 4 quarters in a year. And if I said semi-annually, which doesn't happen that often, but semi-annually would be twice a year. So N, we've got to make sure we read the question and make sure we figure out what N is first. And if it's annually, it's one time a year. If it's monthly, it's 12. If it's quarterly, it's 4. And once in a while, you have semi-annually, and that means 2. So let's do a couple of these. We're going to do a couple of them where we use the present value to find the future value, and then I'll give you some where you have the future value and you want to find the present value. So we'll do one of each, or at least a couple of each. And we're going to do one where we find the future value, find the A. When I say future value, that means we have to find the A. And I'll come up with one here. Let's say $5,000 is invested at 3% compounded quarterly for, how about 8 years? So we've got to make sure we read the directions. This one, we want to find our future value. So that means we're going to be finding the A. In a moment, we're going to do a couple of them where we find the P, the present value. So future value is what you would have at the end. So if I put $5,000 in the bank, how much would I have in 8 years? Now, when we write up our formula, we need to figure out what pieces go where. So let's see what we've got. A. A is the future value, and we do not know A. So that's going to be the question mark. P is the principal. How much money did I invest? I invested $5,000. So P is the principal. That's how much money we put in. We put $5,000 in. R is the interest rate as a decimal. So that's 0.03. T is the number of years. And in this case, it's going to be 8. And N. Okay, N is going to be 4. Why is N going to be 4? Okay, it's quarterly, right? So now we have all the pieces, and we're going to plug it all back in. So plug the pieces in. Make sure you put them in the right place. Okay, so there we go. So I plug my values in. Now the first thing I'm going to do is break up the inside. So let's go ahead and do that. So we've got 1 plus 0.03. Divide that by 4. And that gives me that, right? So I did that first. So the first thing I did was I just typed it in, right? Divided, and that gave me that. So now we've got 1.0075. And what am I going to raise it to? Well, 8 times 4, that is 32. So is everyone okay with how I got that? Right, let's do that again. 1 plus 0.03, divide that by 4. Okay, so that comes out to be that. So that's what we want there. Now, what are we going to do next? How would I finish this out? So I've got it all ready to be simplified down. Okay, depending upon, again, which type of calculator you have, is what you need, how you need to type it in. So I would type in on this calculator 1.0075. We've got to take that to the what power? 32nd power. Hit equals. Gives you that. Multiply it then by your 5,000. And then that means in 8 years, I should end up with $6,350, and it looks like 56 cents. So that's going to be your answer on that one. So you would end up with $6,350.56. We've got enough time to do one of them where it's find the present value. So this one was a future value. Now we need to find one that is the present value. So this one's going to be finding the present value. You've got to make sure you read the directions. So this one's going to be done a little bit differently. We want to find our present value. And let's say $9,000 invested for 3 years at, let's say, 12% compounded monthly. So first thing we have to do is identify the pieces and where they go. So we want to find the present value. So it's a little bit different. You've got 4 questions in your homework. 2 of them are future value. 2 of them are present value. So you need to make sure when you work these out that you know what you're finding. So we are going to be finding the P. Begin by writing up your formula. A equals P times 1 plus R over N to the NT power. In this case, this 9,000 is the A, because that's how much money you end up with. Because we're going to find the P. We want to find the present value, so that means the 9,000, that is your A. Then we've got the P that's unknown, so that's our question. We have an interest rate of 12%, so that's 0.12. We're going to do this for 3 years, so T is 3, and we're going to do it monthly, so N is 12. Okay, so n is 12 because we're looking at it compounded monthly. Fill in our pieces. So 9,000 equals P times 1 plus 0.12 over 12, right? And then we're going to take that to the NT power. So that's going to be 12 times 3. So first thing I always do is clean it up. Now we are going to have to do a little bit differently in this case, on this one. So first thing I do is I do the inside. So let's go ahead and do the inside first. And I'll use the most common type of calculator. Most of you have this type. So 1 plus 0.12, divide that by 12. And that gives you 1.01. And 12 times 3, that is 36. Okay? Is everyone okay with that so far? Now, this one's a little bit different because we need to find the P instead of trying to find the A. So, what are we going to do? Well, we're going to go ahead and evaluate this down. So we're going to work on this side, find the number, divide to get the P by itself. So let's go ahead and take our 1.01 and we're going to raise that to the 36th power. And we're going to go ahead and write this out. And I'm going to take this out to 5 decimal places so I can get an accurate answer. So 5 decimal places should be more than enough. So that's 1.4307 if we round 7 times P, and that equals your 9,000. So we had to do it that way because it's a little bit different from the other ones. Now, how do we get the P by itself? We simply divide. And you can use the memory in your calculator to keep the answer if you want to, or you can just write it down. So let's go ahead and finish this out. And so now we've got our 9,000. We're going to divide that by 1.43077. And that gives us now $6,290. And if we round, 32 cents. And that would be your answer for that one. And that is the present value. So that tells me then, if the bill was $9,000 at the end of a car loan, I actually took out the loan for $6,290.32. So what's your homework going to be? Well, your homework is now going to be that 4.2. I've got the sign-in sheet. I'll pass that out. And I also have graded homework. So 4.2 is going to be your new homework assignment. And let me go ahead and pass out the sign-in sheet. And I've got quite a bit of graded homework as well. So before you leave, please pick up your graded homework. That way it doesn't keep piling up here.